details that's in the R7 release. So I highly encourage you to check that out if you're interested in R7 and what's new and going to be available when that gets released. We also have the IoT demo upstairs. We have a train track set up. If you've been here in the last year or two, you may have seen it before. We have enhanced it. There's new features to it, so I encourage you to check that out. And then lastly, you know, the OSGi Alliance puts this event on. We do a lot of work. You know, all the work that goes into the specs is done by volunteer members. We can always use more help. We can always use more members. So another thing you could consider, or we hope you consider, is joining the Alliance, getting engaged, learning about what we do. Come talk to me if you're interested. There's information up at the IoT demo if you're interested for more information. So please check us out. We could really use your help. So with that, I'll turn it over to one of our proud members from Adobe, Robert.
Thank you.
His talk on scaling up development.
Yeah, so that's scaling up development of a modular code base. Nice title, isn't it? Sort of looks like an SEO expert wrote that, chock full of keywords. I considered talking about Kubernetes and machine learning at the same time, but then I decided it was a bit too much just for this one talk. Now, about myself, my name is Robert Munteanu. I work with Adobe Systems in Bucharest, Romania, on a product called Adobe Experience Manager. I'm a member of the Apache Software Foundation. I'm closely involved with the Apache Sling and Jackrabbit projects. Now, all of these projects/products are built on top of OSGi, make a lot of use of OSGi, and are highly modular. Now, that has led me to some, well, interesting experience in terms of development, which formed the basis of this presentation. Now, we'll be talking about modular development in general, as opposed to modular deployment. Then dive into sort of the pillars of that I consider of modular development: source control, build tools, and continuous integration. How do you handle development environments, communication? And in the end, we'll try to tie them up with a nice ribbon and call it a day. Now, I assume that most of the people in this room have had good exposure to what we know as modular deployment. That we have known in OSGi for quite some time as independent modules, independent bundles that are deployed separately from one another. No connections here. Or more recently, microservices. But there hasn't been a lot of talk about what modular development means. So you may be working with 2, 5, 10, 20, 50 source projects, but are they still in the same source control? Do you have a unique build job for them? What is your continuous integration setup? Now, if you were in this morning's B&D Tools workshop, you probably saw that we quickly got to 4 OSGi bundles. We had some auxiliary modules as well. So they start increasing pretty soon. Do we need to do something about them at some point or not? So that's basically the idea of, hey, do we want to do modular development or keep it as a single monolithic development, which is, let's say it's okay, but as long as you're aware of the pros and cons of doing monolithic development, let's call it. And if we want to be a bit academic about it, we can sort of imagine, I suppose this isn't very readable, especially to the folks in the back. So let's imagine we have these 2 axes. One is deployment. Do we have it not modular or modular? And this is development, not modular or modular. So this is the nothing is modular quadrant. And you say, well, I don't do modular deployment. I don't do modular development. You can think about it as a old school PHP web application, right? All the front-end files, the templates, the components, the scripts are all in one repository and they get deployed in one go. And that's fine. I mean, if you don't need anything extra, why complicate your life? If you're programming in Go, I don't know, or doing static linking in C, that's also your maybe your model. Or maybe that's closer to modular development, but monolithic development. We have multiple repositories, but still you do a deployment, a single deployment in production. if you're doing a classical Java Enterprise Edition application, where you have maybe a separate repository for your WAR file, then servlets, then EJBs, then whatever, but they still get pulled into a single deployment unit, a WAR file that goes on an application server, or a jar file that is executable. So that's the second one. Now, the third one is someplace where you probably don't want to be. That is, you do modular deployment, but non-modular development. It's a bit of a stretch, I know. Okay, I've seen it done. It's not something very nice to do. It's typically when you have one single IDE project or one source control project and you generate multiple artifacts from it. Usually that sort of goes against your build tool, and it's someplace where you typically don't want to be. Now, modular development and modular deployment is the main focus of this talk, and it's basically when you have multiple repositories and these are deployed as independent units, microservices or OSGi bundles. Now, I said it was a bit of an academic distinction, so don't really think of your project as being modular, yes, no. Is my project fast? Yes, no. It's the same question. Does my project have enough quality? Yes, no. It's more of a tendency, so you can find yourself along the deployment and development axis. You can find yourself here or here, okay, but not here, not where you have monolithical deployment and modular development. That's a bad place. I allow no dots here. Usually it all starts with source control. There's the big debate is whether when you have multiple repositories, is you ask yourself, do I want one source repository or do I want multiple ones? Now, traditionally, you might remember CVS with good fond memories, or then we had Subversion, which is better, faster, everything improved CVS. But they sort of set the norm that you had one source repository that contained everything. Nowadays, people are moving towards distributed version control systems, but interestingly enough, not everybody. So there are pros and cons to having a single versus multiple source repositories. So let's take a quick look at that. The single repository has the great advantage of making most things simple. So you want to get all of your projects, that's fine. You do an SVN checkout from a path under your SVN repository, and then your 5, 10, or 50, or 250 projects are all there. You can very easily search across the whole source code repository. You do a grep or whatever you want to use. You can commit atomic changes. You can do global tagging. So there are many things which are easy when you're using a repository. And the people who are actually using these kinds of tools at scale are so happy. They give them sort of a marketing brand name. They're calling them monorepos right now. And they're investing a lot around tooling and infrastructure. But on the downside, if you have one such big repository and you keep adding stuff to it, operations often become quite harder. Now, in the Apache Sling, we had, you can't read this, but I did a SVN list on all the tags, and there are close to 1,500 tags. So tagging and branching become a bit of a mess and hard to navigate. If you see a developer branch in a repository with 200 projects, now, who is that going to belong to? So things become not so clear anymore. And usually when you want to scale a monorepo, you're pretty much on your own. All the people who are talking about using monorepos at scale pretty much build their own tooling infrastructure, patching their own the software behind their source control repository to make it work for them. So monorepos can work, but in my experience, they're a lot of investment. Now, if you're doing multiple repositories, it's sort of in a mirror compared to the monorepos. Okay, they're easier to operate. You do a git clone on a smaller project faster. On the other hand, you can't do easily a search of all the Git repos. You can't do atomic commits or pushes. But the good thing these days is that everybody's using probably Git. There's GitHub, GitLab, Bitbucket, and many others. And everybody's building tooling and processing and extension points around them. And if you're going to use such a distributed source control repository, you're going to benefit either directly because the tooling is already there, or indirectly because all of the extensions, or extension points rather, are already there. So there's a lot of stuff coming from free, which is a price I can't easily say no to. And one of the things which comes for free is the ability of aggregating multiple small repositories into a single image. Now, this is an example tool called Repo from Google, used on the Android project usually. I want to stress out that I usually present an example, how to solve a specific problem, but there are many more solutions out there usually. I just want to point out the classes of problems so that you're aware of them and that there are solutions. So this tool is based on XML. Everybody loves XML, or at least they did, I don't know, 5 years ago when this tool was initially designed. And it's basically a gigantic list of projects. It says project path equals something, name equals something. And then I added here 2 projects because I have a small slide, but you can add hundreds of projects and have them centralized in your manifest. And then there is some default declaration that say, hey, use this remote, always use origin remote, and always use the master branch. And you can do a couple of calls. You do this repo init, and you give it a git URL. The git URL actually contains this XML file, right? So you say, hey, get me this XML file. And then because I have this fetch, which is 2 dots, it knows that all the project paths are relative to the path of my repository. So that makes for really nice, let's say, GitHub organization layouts. You have something /org, and then a manifest.git, and then wham, all the way down, or your other repositories. And well, when you get this, you initialize this repository, and then whenever you do a sync, it fetches and checks out changes for all the projects that you have defined here. And what you achieve here is basically client-side aggregation of Git repositories. It's, for instance, much easier to do a search. You do a grep or whatever tool you want to use that searches all across the repositories because they are checked out in the same directory. Now, it's important to stress out that this is sort of a client-side Git tool, so you will not be able to do orchestrated synchronized commits. It doesn't do that. It doesn't fundamentally change the way the Git repository behaves. It's still 5 or 10 or 200 repositories on the server side. But then again, I would argue that you don't actually need to have synchronized commits in multiple modules unless you're doing something like trunk-based development where every commit generates a deployment and so on and so forth, which, well, is a module that I've seen, but not all that often. So Repo tool allows you to get this aggregate image over your Git repositories. And this is actually a perfect combination of a small screen and unreadable bash shell script. So it's just an example that you can very easily automate it. You can tie into, this is a call to the GitHub API, listing all repositories, and then some unmaintainable shell script which extracts the names and sorts them and creates an XML file. Now, and the point here is that you can script and automate creation of repositories if you have the need. If you're managing if you're creating and deleting and renaming repositories very often, I don't know, daily, weekly, you can do this as a script, and you can do this as a Jenkins job if you prefer, and you will never have to touch that XML file again. And I added the shell script version because I said, let's do something reusable and maintainable, and I wrote a Groovy script that was 4 times larger. Now, that's probably because I'm a very crappy Groovy programmer, but anyway, there's something to be said about shell scripts being short. Now, another scenario in which you might find yourself in is migrating from a single repository to multiple repositories. Now, in my case, we recently did this from Subversion to Git. It was loads of fun. I'd do it again anytime. And there's usually a couple of steps that you need to follow. The first thing is whether you're moving from the same source control, from Git to Git, for instance, or from a different one, from Subversion to Git. For SVN to Git, there's obviously Git SVN, which does a good job of getting 95 or 99% of the cases done. In our scenario, it didn't get all of the history done, but since we also kept the subversion repository, we said, okay, that's fine. You don't really need to get everything right. And then you do a clone from the main repository, and this is your source in this link. And then Git has this nice facility of local checkout. So if you clone from the file system to the file system, it's incredibly fast. So we have a very large Git repository, and it's under 2 seconds to do a clone on my laptop. So that allows you to really experiment fast and run the migration process locally quickly. And then let's say that we work in this subdirectory, which is the destination, the Sling engine, and we do, to paraphrase a famous quote, as the pictures, we rewrite the history. So Git, as you probably know by now, allows you to shoot yourself in the foot quite easily. And it has this wonderful command called git filter branch, which basically allows you to take each commit and alter it in any way that you see possible. Author, committer, commit message, even the actual tree, the actual objects that are changed by that commit. And for lazy people like me, it even has an option called Subdirectory Filter, which allows you to isolate a repository to one of its subdirectories and then moves it at the top level. So basically everything I need to do, this filter branch call does it for me, which is fine. The next step is getting the equivalent of a Java memory leak, which I guess would be called a tree leak or a reference leak. Git is very helpful and saves the original references, the branches and the tags. And that means that you will have a large Git repository containing the old history and the new history. So then we nicely ask Git, okay, I know what I'm doing. We delete all the stuff under refs original, and we no longer get that Git memory leak. And with just a few commands, we extracted the big repository to a small repository. And the reason for me personally, for why Git is not enough if you want to have a large number of repositories in it, is that Git, for good measure, asks that you have all the commits that it has when pushing. So if someone has pushed in the meantime to Git, you get a non-fast forward exception or something like that and say, hey, you need to pull the latest state, which you do and push again, which is fine until you start releasing projects. And lots of people start releasing projects in the same Git repository, which means that you start to build, and it takes a couple of minutes, runs the integration tests, validates, blah, blah, and you say, hey, I'm ready to push. And then somebody else has pushed in the meantime. Say, okay, you pull and you start again. And this game goes on and on. So Git is not such a hot option if you're doing lots of concurrent pushing, especially with a release validation. Now, ideally, you plan this ahead. So not immediately after you split all your repositories, okay, so what am I going to do about that build server thing? So let's see what we can do. So usually when you have a single source repositories, you're very much tied to reactor builds in Maven speak, or an aggregate build, which is an extremely convenient way of building all modules by running one command, and that the POM.xml or whatever you're using recursively includes multiple POM.xml files. Okay, so why the Greek letters? Now, this is a very simplistic way of me saying that the reliability of a system is equal to the product of the reliability of its individual components. Now, this I think is important because you can view a reactor build as a system with a certain reliability, and that reliability is given by the reliability of its individual components. So if you have a reactor build with 100 modules, and 99 of them pass all of the time, and one of them fails all of the time, the reactor fails 50% of the time, let's say, your reactor build will fail 50% of the time. Now, this may or may not affect you, but as the number of modules grows, the chances of something going wrong increase. So in the Sling project, we have, I don't know, around 270 modules, I think, and it was practically impossible for one of them to not have a problem at a given time. So reliability is one big issue with reactor builds. Another one is turnaround time. So as a developer, when I commit a change and I would like the CI to validate it, I do not want to wait for 30, 40, 60 minutes. If the module build that I did takes just a couple of minutes. So splitting up a Reactor build into multiple small modules also give you a much, much faster turnaround time. And usually, although the guys administrating your infrastructure will be scared when they say, okay, you had one job, now you have 200. Even if initially they're scared, the load on the server will be much lower. Because instead of building 50 minutes for each change, you build 2, 3, 5 minutes for each change, which is a definite improvement. Now, if you're moving from a single build to multiple small ones, you would have benefited, maybe without being aware, of another advantage of the Reactor build, which is that dependencies are resolved in the same reactor. So you have module A, which depends on a snapshot of module B, and they're in the same reactor. When you do a Maven build, the dependencies will be satisfied by the Reactor build. Now, if you move them to separate jobs, that's no longer the case, obviously. So one option is, the easiest option is to use Maven install and always run a single machine, run your builds on a single machine. But as soon as you want to scale to multiple machines, you will need a Rusty bucket for a Maven repository, or you can use a readily available product on the market. There are many of those, but the bottom line is if you split your build, you're probably going to need a Maven repository to host your snapshots. And then make sure that all your other builds try to update the snapshots whenever they start. Now, I like automation. I like for loops, as they say. So we had a problem of how do we maintain Jenkins jobs for a large number of repositories. Now, using the UI for 1 to 5, 10 modules is fine. But as soon as you start hitting a certain scale, you can't really maintain those by hand. So we ran into something which is called the Jenkins Job Dsl Plugin. And I'm not sure if you're into computer games, but if you reach a final level where you have this sort of boss character to fight, and outrageously he keeps spawning more minions to fight you. So that's exactly what this job does. So it's called the seed job, and it's a Jenkins job that creates other jobs. So in here we have a list of modules. And then for each module and for each supported JDK, we define a Maven job. And we have some common settings here, like what the goals you want to use, clean, minus use, clean deploy, and all the settings that you would actually enter in the Jenkins UI, you can do in this declaration. And obviously, since it's a script, you can generate however many jobs you want to. So that's a nice way of automating the way you do Jenkins deployments. And there's I sometimes get the question of what's the relation between this and the pipeline plugin, and the difference is that they're completely unrelated. I mean, they're both sort of groovy code. They both can be defined as files stored in source control, but this is a tool for defining multiple jobs, and the pipeline orchestrates a single job. So they can coexist together quite easily. Okay, so you did that. And then you ask yourself, okay, it was easy for me to sort of see, to keep preferences and code formatting and all of that in check when I had a single project. How does this split to modularity this modular split affect me in terms of development environment? So one approach that I've seen done in practice, now this is completely unreadable, but the main point is that there are 4 steps. And this is about a product you probably heard about already, even here, called Eclipse Oomph, which is a sort of end-to-end tool for provisioning Eclipse installations, workspaces, preferences. And it allows you to define a list of, allow users to choose what IDE they're building on top of. It can be a regular version of the IDE or one which has multiple features or additional plugins installed. And then what projects to check out from source control. So you can also build a list of projects that can be displayed to the user with what branches to choose and nested with descriptions, very pretty, you can't see them. And then there's a list of manual overrides where you set stuff like, hey, what is my username and password for connecting to Jira, or the credentials for GitHub or stuff like that, or do I want to set the workspace location to something custom. And then finally you get the final confirmation list and press finish, and a couple of minutes later you have a new Eclipse setup with all the projects checkout and preferences and Git repositories, which is fine for a certain scenario, which is the scenario of a large organization which has a standard development environment and a fixed set of modules that people work on. If you're looking for long-term contributors, this is probably a very good solution. And one extra thing is that it takes a bit of time and skill to actually develop the definitions behind all of these windows. I mean, I wasn't able to do it in a couple of hours. So that's probably to be done if you expect a certain return of investment. Now, if you're looking for a more lightweight approach, which says I don't expect people to build or update their Eclipse IDE for myself, but instead would like to make sure that I get consistent formatting, commit templates, and a couple of things by configuring their IDE. I have prototyped an approach which says I would deploy my IDE preferences as a Maven plugin. So just take whatever file your IDE generates, put it into a Maven artifact, deploy it, and then create a small Maven plugin that reads these preferences and at build time configure, just writes the files into the local directory where the IDE would expect them. And if you're for Eclipse, there's even the nice M2E integration, so you don't have to actually run a build whenever you import it. The Maven this plugin runs and just writes the preferences in time. So that means that each project with this plugin and this definition has the same preferences set. And you can do a bit more structured configuration for things which are too small to warrant their own property file, like commit templates and task repository associations. Now this isn't public yet. I'm almost done with that, let's say, but we can discuss if you're more interested. Now in the communication part, it's a bit similar to the others. Do you want to have one communication channel, whether it's a mailing list, Slack channel, IRC room, whatever, or do you want to have multiple ones? This is very beautiful. You can't see anything. Anyway, this is a mailing list archive from the Apache OpenStack project. And the interesting thing is that all of these email threads are tagged in a free form by having some keywords in their brackets. And it's sort of an expression of the fact that it is viable to run a large project on a single main communication channel by enforcing some rules and educating the people that communicate with it to use proper subject lines and tagging. Okay, so why does that help? Now, the main advantage of a single communication channel is A, that I only have to subscribe to one thing, and B, that I know all the people that would be interested in my email are there. The downside is that it can get noisy. So if you're getting 50, 70, 100 emails per day, it can quickly become tiring to read all of those and decide whether they're worth your time or not. So here is where the tagging and the proper subject formulation comes into play. So for instance, if I'm interested in the OpenStack project in just the infra tags, I can easily set up an email rule which says if email is tagged with infra, keep it in my inbox, otherwise move it to a folder which I will read today or never. Or I can set up a rule which says if the email is not tagged with infra, mark it as read because I don't care about it, or delete it. So that's sort of one side of the coin. The other side of the coin is, say, we have a setup where everyone can create an individual channel, which is fine, sort of, only that, well, I cheated and took an old screenshot from an old Slack version which says browse all 855 channels. Now, this is usually a bit time consuming to find out, okay, I have a large number of Slack channels, where do I want to be, which is okay, it's a one-time cost, but in 2 weeks, new Slack channels will be created. And then I usually don't spend the time to periodically review my Slack teams and say, hey, which new channels should I be in? Otherwise, it's more or less mirrored with the central communication hub, less noise, less discipline, more focus, but you have to take more care about finding the right people. So is that my recommendation? One single mailing list rule them all? Well, yeah, maybe, provided that the mailing list is properly curated and there's enough discipline for people to use proper subject lines and tagging and keep all of the non-essential information out of it. By non-essential, I mean administrative, personal time off, daily stand-up status, and all of that, which don't belong on the development mailing list. Now, wrapping up, so how did I get to do all of this? We had a very specific need. It says here 256 repositories in the Sling committers team. Now, it's 257 now, but I have a thing for powers of 2. So we have this large number of projects and needed to do proper management for them. And to sort of give you an idea of what it would mean to evaluate your project, I said it's not a binary thing, it's not a yes or no thing. Well, now I say it's not even a scale from 0 to 1 or from -1 to 1, how modular is your development. We try to think of these pillars that we have: communication, build, CI, ID, and source control, and evaluate how well we do with each of them. So that's the way it looks for us. We are fine with communication, build, and CI are properly modularized. We're almost done moving to Git with individual repositories, so source control is here. We haven't done a lot of work on IDE and helping developers with our very modular projects. Now, if you take one thing, it's scripts everywhere, basically. My experience is that modular development requires lots of glue and you sort of tying things together in terms of development. Now, if you want to be a bit more serious about it, in the center, it's always your source control. That's the truth. And then you have your continuous integration server, and the round bubbles are things you do yourself. And you do a little scripting or a little integration to automatically generate CI jobs. And then your ID list of modules can also be generated from SCM. And your coding standards are held in the SCM. And the list of modules can be deployed as an artifact repository, and so on. You can create all of these integrations for yourself to make your life easy when you're working with a large number of projects. And it doesn't have to stop here. If you decide that, for instance, when communicating, a large number of channels or mailing list is what's good for you, you can have integration between source control and the communication hub, whether it's Slack or emails or whatever, and create mailing lists or Slack channels whenever a new repository is found. You can even automatically invite the people who committed 3 times or more on a certain source repository to a Slack channel or to a mailing list. The point is, always try to be automating, because otherwise you'll get bogged down in the number of projects. Now, this is a list of supporting tools that I've used and found useful. These are a few examples of people actually doing modular development, whether it's OpenStack, whether it's our Apache Sling, whether it's WCMIO, where you can see more how these have been applied in practice. And finally, the mandatory slide that says sign in and vote +1 and nothing else for this session, or don't vote at all, but leave a comment, because that's probably the most important thing to us speakers. Okay, that was basically it. Thank you. What are your questions? Yes, please.
So I work for a company. We are transitioning toward more and more modularity.
Yeah.
And this was particularly interesting for me for that reason. Now, when you build with Maven and you split from maybe few repositories with many modules into many individual repositories when there are dependencies in between them.
Right.
So how do you deal with the fact that maybe an upstream module changes, a new version is out, and all downstream modules should start consuming it immediately? Do you do this as part of the build job by, I don't know?
Right. So we actually don't have that problem because our product is defined by a list of bundles, basically, and that product definition lives in a separate project. So if we have project A, which depends on product B, when a new version of B is released, we don't update product A.
You don't?
No, because only if needed to consume new APIs. That's it. But actually, I would automate it.
But in that case, it means that if your consumers want to use the latest version, they have to do some dependency management in Maven to force the newer version of the upstream project.
Well, we updated in the, let's call it the product definition. But if the old, if from the point of view of API, so if we don't need an API change, we don't update it because we don't actually use product simple module dependencies to package a product. But I would personally, I've had this question before, I would do a bot which listens to these either tags in source control or deployment events on your Maven repository and issue a pull request with the change, not necessarily merge it automatically. Okay. So, yes?
I also have a question about this aggregate build approach. How would you handle basically the caching of the generated artifacts, especially in case if some of the sub-artifacts has an error, like the reliability aspect you mentioned? For example, some submodule in the middle of the whole build process fails. If you run the whole build again, you basically want to start again in the middle and not at the beginning and build everything again from scratch because that's the same as the single repository build then. How do you handle this?
Well, we build sub-modules individually. So we don't, we have a separate build job, we have 200 and something build jobs on Jenkins and only one triggers.
Okay.
So if you still have a single reactor job, I think in Maven you can do Maven-RF, resume from, and you give it a certain module to start from if you want to resume a reactor build. So after 50 modules, 51 fails, you can resume from 51. But my advice would be just run individual builds, and the Jenkins Maven job type, which is actually discouraged but works fine for me, can trigger builds based on other builds deploying snapshots. So you have project A, which depends on B snapshot, and B snapshot is just deployed. Then Jenkins will build module A again. So that's sort of my answer to it.
When you want to build without Jenkins, then you have to build everything because you rely on Jenkins for the dependency management.
Well, you would build, the assumption is that Jenkins builds and deploys everything to a repository. And if you do a local build with -u to update snapshots, then you would, in a single module, you only build a single module, any snapshot dependencies will be in the repository and will be pulled in. So you actually don't need to do anything special locally. It's precisely the same as a Jenkins job.
Thanks.
Please. Yeah, that's you.
You mentioned what as building up into multiple repositories and using the repos script to basically check out. How is this different from creating something? I think there's something called git modules.
Yes.
Say minus recursive, and you check out from multiple modules. So how is this different?
Right. So my understanding is that Git submodules are good for tracking other repositories at a specified revision. You can't yet say, oh, I want all of these 50 submodules in the master branch. It doesn't do that. When you want to update a submodule, you do a pull and then you commit that revision again in your Git submodules file, and it's not done for properly. It's more, I think, done for tracking third-party source dependencies. So that's why I would use repo. And also repo has some support for doing commands over all the repositories, like start a branch over all the Git repositories. Okay, I think our time's up. Thank you. I'll be here for the rest of the day if you have more questions.